everyone. I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic we selected for this video lecture is problems on double integrals. We are going to discuss in detail about definition of double integrals. That is, what are the formulas are formulated regarding double integrals. We are going to discuss. Using the double integral, we are going to evaluate area based on those problems we are going to solve. The double integral is nothing but to find the area of a particular region in two-dimensional, that is xy coordinates. Then it is Cartesian form. The basic concept behind this double integral is a particular region is there. That region is capital R. That region we are dividing into n regions. That is, this is del R1, del R2 up to del Rn. What about this delta? This delta, it's nothing but this region interval we are taking, a closed interval from xi to xi minus 1, xi minus 1 to xi. If it is del xi, this delta, how it is? It is defined as xi minus xi minus 1. That is, from xi minus 1 to xi, this closed interval, all the points are connected to this region. They defined the function f of x comma y. That is, we are going to calculate the area, that is the function into this particular region, that is delta R1, plus the function into delta R2 up to n times. Suppose in case, now this particular region we divided into up to n. If it is this n up to infinity, then one particular stage we are dividing this region into some space. That is, it is the region, it is, the points are there. At particular stage, this region the dividing will come to an point. So based on this concept, the formula which is formulated. So this is the formula, that is a double integral. The capital R represents region. F of x comma y, it's nothing but that is a function in two variables x and y. The dr is the region. There is the area. If it is two-dimensional, that's what it is written as dx dy. Now it is, if it is polar form, the polar form, it is Cartesian, it is represented in terms of the coordinate x and y. The polar form in terms of r and theta. The interior integration, which is defined for the variable, the radius, that is the radius from R1 to R2. That is the reason we have to do the integration with respect to R first for this interior integration. The outermost one with respect to theta. Even in the Cartesian form also, we will do the integration. This innermost is a function of x and defined for y. If it is defined for y, first we will do with respect to y we will do it. Here it is written dx dy. So the innermost is defined for x. So the limits rules are there. If the four limits are there, the four limits are constants, then we have the liberty to do it any one first. Either we can do it with respect to x first or y first. The problem: find the area enclosed by the parabolas. Y square equal to 4ax and the lines x plus y equal to 3a and y equal to 0. In the first quadrant, that is the area which we are going to calculate that lies the particular region in the first coordinate, it is given in the question as a condition. Solution. So we are reading the question and we got an idea. We got a clear picture about it. The given problem is Cartesian form. Because the coordinates are x and y. If they are r and theta, our direction, our mind functioning direction towards polar form it will go. But whereas here x and y variables are dominating. So it is Cartesian form double integral. Only two variables are dominating. That is the definite integral. We know the definite integral. Integral a to b f of x dx. This is a definite integral related to one variable. That means a function which is defined for one variable. If it is extension to two variables, then it is becoming double integral. That is only our topic, double integral, the extension of definite integral. So now x-axis, y-axis, we named it as the horizontal line as x-axis, the vertical line as y-axis. The origin, we named it as O. The coordinates are 0, 0. Fine. Now, y square equal to 4ax, the parabola. So the arrow mark which represents, which says that this is the parabola, it's nothing but y square equal to 4ax. The next one, here the condition which is given, x plus y equal to 3a it is given and y equal to 0. We will substitute here. When it takes the value 0, x equal to 3a. So we named it as, that is at x-axis, the 3a, the point it is cutting. 3a which lies on x-axis. When y equal to 0. That's what x represents 3a, this 0 for y. The coordinate we gave, the point which cut at x-axis is p of 3a, 0. The next one, here y square equal to 4ax. If we simplify this, we will be getting, that is y square equal to 4a into, just now we got it, 3a. That we will substitute and we will be getting the value y as 2a. That is exactly, it cuts at 2a. So this we are naming as a comma 2a. So now this P the point, Q the point, both we joined it by a line segment. So this is the thing it says. So how we formed this line from with this the straight line equation taking x plus y equal to 3a, we joined the points P and Q. So now which region we have to calculate? So now the common point, the parabola, the common region formed by parabola and the line, this complete actually to say, complete this is the region. But we are not considering this part because strictly it is given the region, the area of the region which lies on the first quadrant only to be evaluated according to our question. So we are not at all considering just this part we are neglecting. How to solve this problem? To solve, we are taking the direction. Two ways this area of the region can be calculated. One is vertical way we can calculate, otherwise horizontal way we can calculate. In this particular problem, we have taken the horizontal way. For that, so if we are noticing here, the dotted lines are, that is horizontal lines are there in this which region to be evaluated, that are occupied by these horizontal lines. And we have drawn a horizontal strip towards this facing this x direction. This horizontal strip we have given the name AB. With this we are going to do the evaluating this particular region value. So reading this question completely, the diagram we have drawn it. So the next we will move it with this diagram, we will do the solution. So we can see here the points of intersection of the parabolas. That is here y square minus 4ax, it's fine. We have drawn the parabola. So here we can see it y square equal to 4a of here x is there. This x from here we are extracting, that is y equal to, so sorry, we are taking x equal to 3a minus y. If you substitute here, so now we can see here that is y square equal to 4a of 3a minus y, from which we can extract what is x. So x is nothing but 3a minus y. So substituting here, so y square, this is, we can see to 4a into y, so 4ay, and these two we are multiplying, we are getting 12a square. Thus we have to do the factorization. So the factorization, to do it, here in this place plus 4 is there, here minus 12 it is there. So two numbers we will select it. The two numbers, if we multiply, we have to get this minus 12. If we add, we have to get this plus 4. So the numbers are plus 6 and minus 2. So we are getting plus 4, multiplying, we are getting this minus 12. We selected the correct numbers. So y plus 6a, y minus 2a. This is the factorization method which we studied in lower classes. Now, this y plus 6a, it's nothing but from which we got it y equal to minus 6a. Next, if we this y minus 2a equal to 0, we will be getting y equal to 2a. So y equal to 2a, which lies in our first quadrant. So now that is the reason here 2a it is there. Next, but minus 6a we are going to neglect it because it is there in the fourth quadrant. It comes here, it lies the negative. But as it is strictly told, we have to calculate the region of first quadrant. So the y this point we are neglecting, we are going to consider only y equal to 2a. That is the reason here the 2a which is written. So even here we have seen the previous slide 2a. Just in the next slide we did the calculation how we are getting from this extracting we are getting. So now here the figure which is kept here. So y minus 2a equal to 0, y equal to 2a. Fine. Now the points of intersections is q of a comma 2a, which lies in the first quadrant. The area enclosed in this first quadrant, that is O, P, Q. This region we want it. O, P, Q. And horizontal strip taking, we are going to calculate it. So we are drawing a horizontal strip. The name is AB. Fine. How to do? How to find this area of this particular region? The method is the horizontal strip where it starts touching this parabola, where it ends touching this line. So the parabola starts from the parabola and terminates on the line x plus y equal to 3a. The next one, the horizontal line, the x direction is over. Because horizontal line, it is in the x direction, the starting and ending we completed. Now y direction regarding this horizontal strip we have to see. So y direction here 0, and this point if you are taking here y equal to 2a. So the point we can see it here. So this horizontal strip, so it touches the parabola. Our parabola is this one, y square equal to 4ax. So we wanted x limits. From this parabola, we are extracting x. That is x equal to y square by 4a. Next, where it touches, this touches here this line. This line it's nothing but x plus y equal to 3a. So from this we are extracting x equal to 3a minus y. So x limits from where to where, from parabola to straight line we completed. So next, the limits of y. that is the horizontal strip regarding y direction 0 and 2a. So we can see it here, x equal to that is the integration for x. The x variable depend on y variable. That is, the integral is a function of y for x. That is the reason we are doing the interior integration with respect to x. Compulsory we have to do it. The outermost one for y, that is from 0 to 2a. So now the innermost integration, first we will do it. We know integral of dx, it's nothing but x. So we can see it here, x it is there. And the lower limit is y square by 4a. And the upper one is 3a minus y. Now the leftover is, we have to substitute the upper limit and lower limit. So we substituted in this particular place the upper limit. That is, x place we substituted, we got it 3a minus y. So this is the position for the upper limit. In the place of x we substituted this value, we obtained it. This is a limit formula. That is upper limit minus lower limit. The lower one is y square by 4a. So in the place of x we are substituting. So we substituted and we got it y square by 4a. We completed this interior integrated, and we substituted the limits also. Finally, we obtained regarding with respect to x integration. So now the next one is, so this is the thing, the final, we have to do the steps for outermost integration. We have to concentrate with respect to y. So the outermost integration, the limits are from 0 to 2a. That is 3a minus y square by 4a dy. We can see here, this is 3a. We know integral dy equal to y. So we did 3ay. This minus is as it is. Next, integral y dy, we have to do it. Small integration, the basic integral formula, integral xn dx. It's nothing but x power n plus 1 by n plus 1. Here our n is playing the role 1. So y power 1 plus 1 by 1 plus 1. So we can see it y square by 2. Next, this minus is as it is. And here this 4a is there. Here we have written 4a. Up we have to do the integral y square dy. The same formula. Here n is playing the role 2. So y2 plus 1 by 2 plus 1 equal to y cube by 3. This 3 is moving here. So it has become 12a. The top is this y cube. So now we completed the outermost integration and we have to substitute the limits from 0 to 2a. So in the place of y, we are going to substitute the upper limit value 2a. So 3a, in this place we are substituting 2a, put together it has become 6a square. The minus is as it is. Here y is taking the value 2a. So 2a the whole square, it's nothing but 4a square. This 2 is written as it is. This minus is just written. The 12a is as 12a. Y cube, 2a the whole cube, it's nothing but 8a cube. So now here this cutting we are getting 2a square. So 6a square minus 2a square, we got it, we obtained it, 4a square, the minus and this fraction 8 by 12, taking 4 as a common, the lowest form we have given, the lower fraction form 2 by 3a square. Finally we have taken the LCM, so the 12 minus 2, we got it 10a square by 3. So we will come to a conclusion of this topic, problems on double integrals. First, initially we discussed about definition of double integrals, and in the definition, Cartesian form and polar form we discussed. Cartesian form, in the direction of x and y, the dimensions are given, whereas polar form, radius and angles are important, and that is the function in terms of r and theta, whereas Cartesian form, the function f is defined in terms of the variables x and y. That we discussed in detail through this video lecture, and we have taken a problem. Find the area enclosed by the parabolas, that is y square equal to 4ax, x plus y equal to 3a, y equal to 0. With this, first we have drawn this parabola, and this line we done it. Finally, we have extracted this y value, that is extracting this line condition. After getting 2a, we can substitute here also, that is 4a square equal to 4ax. So the 4a square divided by 4a equal to x. So the cutting we are getting x equal to a. That's what we can see it, a comma 2a. We are getting this the point q. So the p and the q, how we are obtained also we discussed, and we have drawn a line joining this p and q. This particular region, even though it is also a common region, but we neglected it because of this condition. First quadrant, horizontal strip taking, we did the calculation for this particular region area. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.